All right, we are going to do a chi-square goodness of fit test. Executives at the Thinking Channel have decided to test whether educational backgrounds of the channel's viewers are different from the educational backgrounds of American adults aged 25 and older as a whole. The executives have the following information on the American adult population as a whole, obtained from a recent U.S. current population survey. So, 12% have less than high school, 25 has high school, 55 have college, and 8 have higher than college. The executives obtained data from telephone surveys on the highest degrees earned for a random sample of 200 American adults who are Thinking Channel viewers. These data are summarized in the first row of the table. So the observed frequency, 21 out of that 200 had less than high school, 42 had high school, 125 had college, and 12 had higher than college. So we are going to calculate some of the expected frequencies, and then we are going to do a hypothesis test using the 0.10 level of significance to test our hypothesis. And so here, you'll notice in the Alex table that they have some of these calculated, but not all of them. So the 12% of 200 would be what goes in that first box. So if I calculate 12% times 200, my first box is going to be 24. Now the second box, they calculated 25% for high school. So 25% of 200 is your 50 that they already have in there. Third one they already calculated, 55% times 200 is your 110 that they already have in there. The last box we have to calculate again, 8% of 200, so 0.08 times 200 gives me 16. That is going to go in this box, 16.00. All right, sliding down. The next row, I'm not going to fill in because on our graphing calculator, it will give us those values. So I'm going to go back down here. It says what type of test statistic are we doing? We're doing chi-square. We have to do the degree of freedom. Since we have 4 options, less than high school, college, or higher than college, we're going to do n-1. 4 minus 1 would be 3, so I'm going to have 3 in there. And now I'm going to use my graphing calculator, and in my list, I'm going to put my observed frequencies in list 1, my expected frequencies in list 2. So list 1, 21, 42, 125, and 12. List 2, 24, 50, 110, and 16. I'm going to then press stat, go over to tests, and then either cursor down to D or do alpha x to the -1 to bring up my chi-squared goodness of fit test. The observed values are in list 1, the expected values are in list 2. Degree of freedom is 3. If you don't have that in there, change that to 3. And then we're going to calculate. So the CNTRB, that's our values that we are putting in this last row. So 0.375 would go there. You can see the 1.28 on your calculator, the 2.045, which they rounded off to 3 decimal places, and then higher than college, we just got a 1 there, so 1.000. We've got those in there, so now I'm going to scroll down here a little farther. The value of my test statistics, so chi-squared rounded to 2 decimal places would be 4.70. My p-value rounded to 3 decimal places, 0.195. 0.195. Now on here, our null is that they are equal. Our alternative hypothesis is they're not equal. So in this case, we're going to compare the p-value to the alpha value being 0.10. Our p-value, 0.195, is greater than our alpha value of 0.10. Since our p-value is greater than our alpha value, we're going to accept the null being that they are equal. The question, can we conclude that the distribution of highest degree earned by the Thinking Channel viewers is different from the distribution of highest degree earned by American adults? We are saying that they are equal, so we're saying that they are not different. So can we conclude they are different? No. We are concluding that they are the same because we're accepting the null, saying that they're equal. I'm going to hit check here, and it says, yep, I did that one right. So I'm going to go to the next question. Matrimony Monthly is a top-selling magazine that provides information for couples thinking about marriage. Over the years, writers of the magazine have researched just about everything that there is to research about weddings. The popular conception at the magazine has been that roughly 50% of first weddings take place indoors in a church. 30% are indoors in a building other than a church. 20% take place outdoors. This past week, the magazine examined a random sample of 250 first weddings and found the distribution in the first row of our table. So out of that 250, 150 got married in a church, 65 got married indoors but not in a church, and 35 were outdoors. We are going to calculate the expected frequencies based on the percentages. So I'm going to slide down just a little bit so we can see that row on our table. And it says roughly 50% of first weddings take place in a church. So I'm going to take my 250 times 0.5, 50%. So that means that our expected frequency here would be 125. Indoors but not in a church was 30%. So our 250 times 0.3, 30% is 75. The outdoors, they already have calculated for you. The outdoors was 20%, so 250 times 0.2 gives you the 50 that they already have in there. They say to 2 decimal places, but I'm just going to leave it like that. Again, this bottom row in our table, I'm going to do on the calculator, so I'm not going to fill those in. Chi-squared test. Degree of freedom, we have 3 choices: in a church, indoors but not in a church, or outdoors. So n-1 means I'm going to have 2 for my degree of freedom. Now I am going to do my graphing calculator, go to my list, 1 to edit, clear out what's in there. And list 1 is 150, 65, and 35. List 2, 125, 75, and 50. I'm going to hit stat, tests, go down to D, or do alpha, x to the -1 to jump down to D. Observed is list 1, expected is list 2. My degree of freedom, I got to change to 2 this time, and I'm going to calculate. So my test value is 10.83. That's my chi-squared value. Doesn't ask for my p-value this time, it asks for the critical value. So I'm going to go to my graphing calculator. I'm going to do the chi-squared, alpha value of 0.10. My degree of freedom is 2, and I'm going to enter. So my test value is 4.2 decimal places, 61. 4.61 if I go to 2 decimal places. So if I'm looking at my test statistic, this time my test statistic is greater than my critical value. Since my test statistic is greater than my critical value, I have to accept the alternative hypothesis that they are not equal or that they are different. So the question says, can we conclude that the actual distribution of locations of first weddings is different from the distribution in the magazine's popular conception? Yes, we are accepting H1 that they are different, so I am going to put yes. And I almost forgot to fill in this row here from my table. In a church, we have 5. The next one over, rounding off to 3 decimal places, we get 1.333. And then you can see that they have the 4.5 from our calculator. That's your CNTRB information at the bottom of your goodness of fit test. So you can fill those in. And we said, yes, we are accepting the alternative hypothesis since our test statistic is greater than our critical value. Are they different? Yes. I'm going to hit check there. All righty, hopefully that helps as you're working out these problems. I'm going to go ahead and end my recording.